that. I just want to show you. I just want to show you where these formulas come from. Let's write them down and figure out what we do with them. Double angle formulas say this. Sine, we have sine of 2a. Sine of a double angle is 2 times the sine of a times the cosine of a. Cosine of a double angle, we have 3 options. I just did the 3 options on the other page. We started with cosine squared of a minus sine squared of a. We also had 2 cosine squared of a minus 1. And we had 1 minus 2 sine squared of a. So for cosine of 2a, you have 3 options. I always choose the last one. That's my friend. I call him Timmy. No, that's Tim, not Timmy. That's Tim Dog. Actually, his name is not Tim. For tangent, we get this. Tangent of a double angle is 2 tangent of a over 1 minus tangent squared of a. Now, I want to give you things that you're going to use later on in calculus and calculus 2. The stuff that you won't use, I'll get rid of that. How's that? So we use this later on in math. We use these later on in math. I've never had to use that. And so therefore, I rewrite the formula as sine of 2a over cosine of 2a. Because that is something that I use. If you look at your note sheet, you can find out where we live. We are living right here. Double angle formulas. This is where we are right now. Everybody understand? Are you ready to work through the challenge? Yes, the mountain of confusion. You will be ascending the mountain of confusion today. You'll have to decide if you're going to run back down or you're going to try to trek through the top. It's going to take a lot less time to run back down than it is to move to the top. But then you're going to pull a 4 out of 40 on the test if you don't work through it. You don't want to do that. So, let's do it. Given cosecant of x is 2 and x is in the second quadrant, find sine of 2x, cosine of 2x, and tangent of 2x. Instead of writing IDK, which is what people write, start here. Sine of 2x, cosine of 2x, and tangent of 2x. Some people just write that. I still give them 0 points. Some people actually write out the formulas. 2 sine of x, cosine of x. Do you remember which formula I like to use for cosine of 2x? 1 minus 2 sine squared of x. And we're going to leave the tangent one alone because I'm going to use that for effect in a little bit. Everybody okay? And I just think the math works out better. I do. Look at this situation. Cosecant of x is equal to 2. In order to simplify these expressions, I have to know what sine of x is, and I have to know what cosine of x is. As long as I can identify that, then I can simplify these expressions. If I'm told that cosecant of x is 2, do you know what sine of x is? 1/2. Everybody see that? Cosecant and sine are reciprocals. So we know that sine of x is equal to 1/2. Great. Now, all of a sudden, I can start giving you points. You've written down the formula. You've identified sine as 1/2. I have 2 times 1/2 times cosine of x. Notice, you guys, this is the mistake that some people are making. They made in previous hours. You guys always benefit in this class from mistakes other people make. Okay, I don't put the 1/2 where the x is. I don't write sine of 1/2. It says sine of x. This whole thing is 1/2. I replace that with 1/2. See that? Okay, and then here I have 1 minus 2 times 1/2 squared. Well, I just need to figure out what cosine is, right? Well, what is cosine? You've done it before. You tested on it 5.1, 5.2. You were actually really good at it. And thank you. Sine squared plus cosine squared is equal to 1. I put the 1/2 in and I square it. What do you get? 1/2 times a half, 1/4, plus cosine squared of x equal to 4/4. Remember doing this, don't you? Hey, buddy. Subtract the 1/4, you get cosine squared of x is equal to 3/4. Square both sides. Samantha sees it. We have cosine of x is equal to plus or minus the root of 3 over 2. Is it positive or is it negative? Ishka says second quadrant. It's okay. So negative. Thank you. Cosine is negative in the second quadrant. So I choose negative root of 3 over 2. What's 2 times a half? 1 times negative root of 3 over 2, negative root of 3 over 2. Pause. Have we ever shown that sine and cosecant are reciprocals before? Yeah, have we ever done this? Sine squared plus cosine squared is one thing before? Have we ever determined which quadrant things are in before? Yeah. So actually, this is exactly the stuff that we used to do. The only thing that's different now is you're just substituting them into the formula, multiplying it. That's it. So this should, I mean, there's a reason why we try to structure things in math the way we do. So I try to make sure we did a really good job of this back in January so that now, hopefully, it comes back to you. And it's possible I didn't do my job. I'm just saying I tried. So, oh, it's still on. Okay, I thought I paused it. All right, great. So this one, I've got 1/2 squared is a fourth times 2. 2/4 or a half. 1 minus a half. Now, here's the mistake that people sometimes make. They go to find tangent, and here's what they do. They say, well, I'm going to find tangent of x, so I'm going to take 1/2 divided by negative root of 3 over 2. That's entirely wrong. So you're not trying to find tangent of x. You're trying to find tangent of 2x. Well, in order to find tangent of 2x, you take sine of 2x divided by cosine of 2x. See? So we get negative root of 3 over 2 divided by 1/2. And yeah, the book doesn't teach it like that. The book tells you to use the other formula. But again, I'm telling you, you're never going to use that. Well, maybe you will. Maybe you have a crazy teacher in college who actually does this stuff for you, but I just don't see it. I don't ever use it in calculus. I don't think you'll have to. So, all right, keep it clean with the stuff that we want to be able to use. These definitely come up in Calculus 2 a lot, these type of formulas, and Calculus 1. So we're going to make use of them. Now, as I look at these answers, there's something about these results that are making some people feel a little frustrated and angry. What is it that's making you angry? Okay. Fractions, square roots. I'm thinking that you guys are looking, you're saying second quadrant, which means cosine is negative and sine is positive and tangent is negative. Yet, look at our answers. Sine's negative. Cosine's positive. Tangent's negative. Are we wrong? It's double. Exactly. So I just want to be clear about what you're experiencing here, folks. X is in the second quadrant. So suppose that your angle was, let's say, 150 degrees. You're in the second quadrant. Everybody agree that sine's positive, cosine's negative, and tangent is negative? But if you were to double it, 150 becomes what? 300. Which quadrant is 300? Fourth quadrant. Very good. So if I'm in the fourth quadrant, now what? Which one's positive? Cosine. Cosine's positive. Sine's negative. Tangent's negative. See that? So it does work out. We're going to pause. You're going to start the first problem on your worksheet. By the way, we might have people roaming through our classroom tomorrow. Remember those 10 people that were supposed to come by? You guys should act really bad during class. You should complain. You should, like, one person should just say, I am sick and tired of your teaching, Mr. Gantz. You are the worst. We're going to, you guys just, like, walk out, you know? Yeah. Or you guys be really stupid. So, like, if I do, like, 5 minus 3, just start shouting out, 25. No. Oh, that'll be a really good time. Okay. So we have a second type of set of formulas that we want to work through today. This is another IDK question. The good news is that tomorrow we move on to the easiest lesson of the unit. You get through today, you're good. Okay? Tomorrow, piece of cake, upside down. All right? Here we go. We want to take sine squared and we want to reduce it. Meaning we don't want a squared power. Why? Don't write this down, but in calculus, I can't do the integral of sine squared of x dx. Like, I'm kind of embarrassed, but I really don't know how to do that problem. Fortunately, trigonometry gives me a different option. Trigonometry gave me a very, very important formula. On the other page, we had this formula, didn't we? Cosine of 2x was equal to 1 minus 2 sine squared of x, right? We had that, right? And if you wanted to solve for sine squared, you would subtract 1 and divide by negative 2, wouldn't you? And so you come up with this formula, 1 minus cosine of 2x over 2. So everybody see how I could use that formula to come up with this guy right here? You could write this one down. This is a formula that we will use. I know how to do the integral of 1 minus cosine of 2x over 2 dx. I know how to do that. I can do this in 2 minutes, even less. This, give me a couple hours, I'm not sure where I'd be. We could do the same thing for cosine. Cosine squared of x is equal to 1 plus cosine of 2x over 2. And the way that we get tangent is we take sine divided by cosine, so we get 1 minus cosine of 2x over 2, over 1 plus cosine of 2x. What? Logan asked a question. Say it. Why are they all cosine? Because, do you see how if I solve for sine squared, I get this? Well, on your other page, we also had this formula. Cosine of 2x is equal to 2 cosine squared of x minus 1. And so if you add the 1 and divide by the 2, you get that, right? On the previous page, we had 3 formulas, didn't we? And so using those 3 formulas, you could come up with these, but they're all equal to cosine of 2x. That's why they all involve cosine. So it's just how it works out that when you lower powers, you get these things. Now, at the end of the day, whoop, I forgot to write tangent squared, my bad. Tangent squared of x, I'm getting excited because this is really good stuff. So I'm going to look back at this page. So right now, this is where we live. Power reducing formulas. So again, I would always have this sheet out as you're working with the problems because this is what you're going to get on the test. Are you ready to reduce some powers? Yes, let's reduce powers. Just, no, it's called an infinity stone, for crying out loud. It's not a ring. YouTube, just to let you know, I was just called Thanos, okay? All right, which I get, you know, the broad shoulders and the biceps. But I definitely have better facial features than Thanos. Okay, fine. Take a cut of my hair. Fine, I get it. Fine, I'm bald just like Thanos, and I get that we're probably the same strength. And but I have more of a heart than Thanos. Okay. Oh, you guys are all dad. 50% of the universe. All right, here we go. Yeah, dead people will show up tomorrow. Ah! Okay. All right. Here we go. Rewrite the following expressions. First power of cosine. I'm going to get rid of sine squared, and in its place, I'm going to write 1 minus the cosine of 2x over 2. See how I got rid of the squared? That's my goal with this problem. It says first power of cosine. Get rid of the squared and make it cosine. Times, what do I have to put in place of cosine squared? 1 plus cosine of 2x over 2. Hey, they're conjugates, aren't they? It's awesome because when we multiply conjugates, what happens? The middle goes away, right? So let's multiply. 1 times 1? Jeez. Plus cosine of 2x minus cosine of 2x minus cosine squared of 2x. Yeah, great point. We're going to get to that. She said, I thought we were trying to get rid of that. Yep, we are. Creates a problem. We'll solve it. That's what we do. We're mathematicians. So I got, you don't do anything to the 2x. You don't like double the angle. It's just, you just leave the angle like it is. Over, the 2's don't cancel. Rather, 2 times 2 is 4. What does cancel? The middles, just like we thought, because they were conjugates. Very good. You're very smart. So you get 1 minus cosine squared of 2x over 4. Now, I have some people, they just take the problem that far. They're like, that's all I can do. And I'll give you on the test, I'll give you 2 out of 4 for that. You get that 4, I'll give you 2 out of 4. That's fine. But if you want 4 out of 4, you're going to have to carry it on. And Emma brings up the excellent point. She says, we have a cosine squared. We were trying to get rid of the cosine squared. Well, we need another formula. And we're going to make one up. Look. No, you guys are totally going to understand it. Watch. When I went from cosine squared of x and I went to this thing, what happened to the angle? It doubled. Thank you, Emma. It doubled. So when I go from this formula to the new one, what's going to happen to the angle? So all of a sudden, I have 1 plus cosine of 4x over 2. So cosine squared of 2x is just 1 plus cosine of 4x over 2. So now I have a new formula I can use. Well, let's use that guy. I've got 1 minus 1 plus cosine of 4x over 2 all over 4. Now I have a complex fraction. What do I do? Okay, so I've heard some really good things. Eventually, you're going to multiply by the reciprocal, but right now, you're going to find common denominators, right? So I get 2 minus 1 is 1. Is it going to be a positive cosine of 4x or a negative cosine of 4x? Negative cosine of 4x over 2 over 4 over 1. Now, Samantha, what am I going to do? Multiply by the reciprocal, and I have 1 minus cosine of 4x all over 8. That's first power cosine, isn't it? That's my answer. Folks, again, I want you to understand, I am not going to try to waste your time at all. I have taken only the problems. Your book gives you like 8 problems on this. There are only 3 problems that you would need to do in order to be successful in calculus. So I'm having you learn those 3 problems. Guess what? We're doing 2 of them in class. On your assignment, you'll look at the 3 problems. 2 of them we will already have done. On the test, I can only ask 1 or 2 or maybe 3, I guess if I want to, of those problems on the test. You will have seen them all before, okay? Like I'm trying to be as clear and transparent as I can. Got it? So let's do the next one. So sine squared times cosine squared, that would be one type of problem you would be asked to do someday. Sine to the 4th, that would be another one. The other one would be cosine to the 4th of x. And so we're not going to do that one, but these are the 3 that you have to do on your assignment. So let's roll through sine to the 4th. Anybody want to guess where we start here? Very good. Sine squared times sine squared. I first have to get squareds. You want to get rid of them now? They're the same. Yeah. Yes. Thank you. Yep. They're the same, so they go away. 1, done. Boy, we have fun. We have some good times. All right. Very good.
Now we can do the 1 minus cosine.
Good. 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. Are the middles going to cancel now? No way. Conjugates. Very good. So I multiply 1 times 1, 1. 1 times negative cosine 2x is negative cosine of 2x. Then what? Another negative cosine of 2x. And then plus cosine squared of 2x. Again, you don't do anything with the angle when you do that, okay? All over 4. So what can you combine together? Good job. You guys are rolling. 1 minus 2 cosine of 2x plus cosine squared of 2x over 4. Shoot. Cosine squared of 2x. I came up with another squared. Good. You guys see to replace it with the new formula. Sure was handy we created a new formula, wasn't it? So the 1 changes to 2 over 2. The 2 changes to 4 over 2. So it looks like I have 2 minus 4 cosine of 2x plus 1 plus cosine of 4x over what? 2 over 4 over 1. Can I combine any like terms? The 2 and the 1, they're like each other, right? And 2 plus makes, yep, 3. Good. Minus 4 cosine of 2x plus cosine of 4x all over what? Multiply by reciprocal? 8. Ishka. This 2? This 2 comes from, so this is the common denominator from the numerator. So if we look back here, we saw that 2 is the common denominator that needed to be created across the board. Better? Okay, good work. You've covered the most challenging parts of Chapter 7. I want to let you guys know that we are still going to cover challenging material. Finding the 5th root of 1 minus I roots of 3 That's something so ridiculous that we have no idea where to even begin. But you'll be able to do it. If you just think about it, what is the square root of -4? 2i. What's the square root of 2i? You can do that, and I'll teach you how. It's really cool. But we have to be able to handle some of the challenging material. If you're bored with this right now, you could try this. Sine to the 8th of x times cosine to the 8th of x. That'll take you a good 2 pages. But if you want to see that worked out, try to simplify an expression like that. That's a good one. All right, get to your worksheet.